So yeah, we are basically here invited by Wapice. My name is Jukka-Pekka Häkli. I'm kind of like the business side of development person in this Beyond Spot platform. So I'm no means any technical background. So I'm actually old power trader. So don't ask any technical stuff from me. So that's why we have Wapice here. So I'm presenting quickly this use case that we have been preparing with Wapice and also why we are doing this. So quickly about UPM. UPM is actually 7 different companies. We are one of them. So we basically are kind of like the independent business. We do our own business decisions and support the rest of the business areas. And this is basically how UPM is set up. So it is not common in our line of business, where basically the business areas are more integrated than in our case. And this Beyond Spot is basically the optimization and energy management service for industrial businesses. And this is basically developed based on our experience supporting the rest of the business areas. UPM Energy is second largest electricity producer in Finland, mainly CO2-free electricity, so nuclear and hydro is our main source. And we will be adding our nuclear fleet whenever Olkiluoto 3 comes online. Then we have kind of like power plants which are more integrated in fiber and paper business, and then they are kind of like owned by their respective business areas. So we only manage the generation fleet which is not linked to the actual paper making or fiber business. Our line of business is changing quite a lot based on, I mean, you probably have read that there's an energy crisis going on. But this actually began a lot earlier when we have kind of like an ongoing shift from fossil fuels to renewables. And this changes basically the setup of the actors in the market. So kind of like from traditional producer-consumer roles, there's kind of like mixed roles nowadays. So consumer are taking more responsible of keeping the system up and running, and then producers are coming more passive against the market. And this means that the whole kind of like thinking and tools and how you run your business needs to change also. And this is basically kind of like put it on the blunt way. So in kind of like an old world where we had controllable energy production and kind of like an industry on behind it which run in 3 shifts, is changing now into the kind of like production which is passive and produces whenever there's a sun or wind. And this means that the consumer side needs to be adapting more. And this means also that you need to be able to react on more quickly and then also handle much more data than before. And also there's not so much forecastable stuff than before. So it's more like an adaptation, and you need to kind of like think about the probabilities. So you need to calculate a lot more. And also because, I mean, renewable production volumes can change quite quickly. So this all needs to happen quite fast also. Which means then, this we can skip, which means that you actually need to be linked quite tightly to the electricity market. So if there's something happening either on the production side or kind of like electricity generation side, this needs to be mitigated almost in real time in electricity market in order to keep the whole electricity system up and running. So that means that you need to have new tools in place and also kind of like have lots of external data also outside kind of like the industrial systems. So what our platform does, it basically optimizes the electricity consumption against different kind of market prices. It does the consumption forecast and it also trades into the market. So basically we have digitalized business process regarding electricity procurement. Then the use case, this is kind of like one of our paper mills in Germany, in Schongau. 3 things in this. So it was founded in 1887, so it's basically a museum. So there's no like Industry 4.0 there. It has 540 employees, which means that there's 3 shifts running it. So it means that information has to kind of like go between the shifts also, what is happening there. And we are producing a graphical paper, which is basically a market which kind of like goes down. The demand of that goes down 5% per year. So they are on a constant saving mode. And this is kind of like the problem field that we need to, what we are facing basically. Also, it's not like it's one couple of paper machines. There's a lot of other stuff also there. And basically because, I mean, it is almost like a museum. If it would be built today, it would not be built this way. So basically there is this kind of restrictions also. So for the modeling of the whole thing, this is quite complex entity. And what our solution does there is basically we only are using this optimization part of our platform. There's 3 different mill systems that we need to connect. Some of them are only able to kind of like do file transfer, but we also stream lots of data from this whole mill. And there's kind of like 2 different things. So because it's an integrated mill site, so there's a paper production which needs steam, which is then generated with this CHP, 2 CHP plants that we have there. And these are kind of like integrated, which means that we need to kind of like model both of the sites and consider both of the sites when we do this optimization thing. And there are kind of like 3 different time forms that we need to do. There's kind of like 1 to 2 weeks period, which is mainly where we time the maintenances. So there's kind of lots of outages that needs to be done. So we have a price forecast for a couple of days ahead, and then we time the maintenances in a low price areas. Then we have like 1 to 2 weeks ahead. And this kind of like means that we have to be connected into this kind of like a maintenance planning systems and production planning systems. Then we have kind of like a couple of days ahead planning, and this is more linked to then electricity trade or kind of like a procurement of the electricity. And then this is where we then optimize also the flexibilities that we have in paper production process. So there's lots of like storages and operations which you can actually time differently. And then this is what the solution does. And then we have a kind of like this kind of like an intraday bit, which then this is more like an opportunistic stuff. So if something breaks down, we need to mitigate this into the electricity market. So if we have bought electricity and then we don't consume it, we need to sell it when this happens. Or if there's a very, very good opportunities in the intraday market, which is kind of like trading all the time, we can shut down something and then sell the electricity that we have actually bought the day before. In Germany, this is done in 15 minutes intervals, and there's a lot of possibilities in German market because there's no hydro production there, which is the most flexible one. So there's a lot of possibilities actually for industrial consumer to make money with also this kind of stuff. But you need to be quite well connected to the market, but also to the production process so that you can see what kind of possibilities you have in kind of like in 15-minute frames, for example. So, and this is basically then one example how it runs. So basically this steady line here is the average consumption, and the green pillars there show how much we deviate from the average in every hour. So it just shows that when there's a low price, we run the production, and when the price is high, we tend to be not producing as much. So this is how it basically the system runs this automatically. So this bit was then.
Thank you, Jukka-Pekka. I can use this one
Okay.
actually. So, if you would stay there still for a moment, or if there's any questions afterwards. So I mentioned we built a solution together with UPM and Wapice. So short introduction to Wapice. So we are actually founded 1999 in Vaasa, but we have offices in several locations in Finland, and nowadays we employ some 350 IoT and AI experts. So we are not a startup anymore, but basically a experienced digitalization company. And we've actually been part of the OPC Foundation over 20 years already, and making different kind of solutions. So custom solutions for customers, but also product-based, like AI solutions and IoT solutions. And then we have, of course, software subcontracting on different categories, what we do. I promised a deep dive into the technology. So we are Microsoft partner on several levels, and this solution was actually made using the Microsoft tools. And there are several reference architectures available. Some were also presented here. And one of the reference architectures you can find from Microsoft web pages if you search for the Azure Connected Factory Pipeline. And if I get the laser. So there's actually quite often you have to well, as also in this case, you have in the Shongao, you have the greenfield devices and you have the brownfield devices. And you have to connect both old and new devices together first. And then you usually would have some kind of an edge module that is able to send the data. And in this case, it would be the Azure IoT Hub. And then from there, you could connect to the Azure tools. But there are some things that you can actually kickstart or make things smoother. So first challenge comes from the on-premise access. So when you start implementing the edge module, you need to have your development team access to the on-premises. And this is not always easy. So for the R&D team, they need access to the production, unless the production team is able to do it themselves. Then the application development using the Azure services. It's not necessarily straightforward. So some development time and costs is needed without this kind of plug and play modules. So we can actually redesign it a little bit. So first we've actually taken the edge module out from the on-premises, and it's deployed in the Azure virtual network. And from the virtual network we made an IPsec tunnel to the on-site, to the aggregation server. And this is actually really straightforward and secure way to make the cloud connectivity using plain OPC UA. And from the VPN network, then there we use the Azure Industrial IoT, which is then used to connect to the IoT Hub. And from IoT Hub, we have then the native integration to the IoT ticket platform, which is then our solution for the low-code, no-code cloud applications. So it's actually really plug-and-play solution how to make data flowing and speed up things and make fast time to market and actually a really predictable cost structure also. And it also solves the maintenance and access complexity because the cloud development team, they have all the tools here. So those responsible for the on-premises, they can focus on their work, and those developing the cloud solutions, they have all the access and all the tools available. So how OPC UA helped? So it's of course Industry 4.0 solution, simple architecture, like described here many times already, and straightforward interoperability and cloud connectivity with standard tools. And then when we add the plug-and-play modules, the application modules, IoT Ticket is our answer to that. So it's our IoT Productivity Studio that you can use to create production-level applications fast. And it actually solves these challenges that were studied in the IoT Signals publication from Microsoft. So time to market, 37% of those who were planning to adopt IoT had this concern. 33% lack of experts, 31% lack of knowledge, and 25% technical complexity. So with easy to use and plug and play tools, you can put your experts directly working with the solutions and applications directly. So then you can kind of avoid the complexity of technical part and complexity of coding and create easily applications. And it's almost similar picture what Jukka-Pekka had, but actually with IoT Ticket and Azure tools, you can really easily create this kind of a platform of energy services. So you can connect different kind of weather services, open data. You connect your buildings, machines, energy storages, and then you connect the distributed power production. And then, of course, the legacy plants and power plants. And then inside the platform, you can do the analytics and do the tasks for optimizing the energy usage. So that would be it. Any questions?